Our next talk is a platinum sponsor, Celestial AI. We have Ravi Mahatme. Ravi is a senior director of product at Celestial AI, where he leads product strategy and development across hardware, systems, and software for next generation AI infrastructure. His work focuses on solving data movement and scalability challenges in modern AI workloads. Prior to joining Celestial AI, Ravi held positions at AWS and ARM. His experience spans semiconductor IP, high-performance CPU implementation, and neural processing units. Ravi holds an MS in computer engineering from North Carolina State University. Thank you, Ravi.
Thank you, Taylor. Hello, everyone. My name is Ravi Mahatme. I work at Celestial AI in the product team, and I'm presenting today on behalf of the whole Celestial AI team. So Celestial AI, we are the creators of the Photonic Fabric technology platform. It's a photonic interconnect technology that delivers ultra-low latency in the range of nanoseconds, lowest power, about 2.4 picojoule per bit in Gen 1, and terabits per second of bandwidth. It's the only optical interconnect technology that can be integrated right in the middle of a silicon die, bypassing the beachfront. That's typically the restriction for silicon today, right? And using our photonic fabric technology, we build connectivity and system products to transform AI and HPC infrastructure. Today, we are focused on primarily two use cases. Number one is scale-up connectivity, and the other is shared high-capacity, low-latency memory. So the Photonic Fabric link, or the PF link as we call it, is a compact, thermally stable optical link. As I said earlier, it's thermally stable, and which means it can be integrated right in the middle of your advanced CMOS ASIC, TSMC 5 nanometer, 4 nanometer, and directly packaged with high TDP AI processors. It's fully compatible with standard packaging technologies, whether it's CoWoS S-like, CoWoS L-like, or similar from multiple OSAT vendors. So it's you can use any OSAT vendor. Because in the technology, we use linear drive optics, so there is no DSP, which helps us achieve a very high, very low bit error rate, and lowers the power consumption. And we take care of the full EOE link optimization that includes FEC, CRC, FLIT replay, link, etc. So a quick look at our product portfolio. So we like to classify our products into two categories. The first is connectivity products, and the second is system products. So in the connectivity products, essentially for XPU to XPU connectivity, customers can adopt our products in three forms. First is Photonic Fabric chiplets. So these are standard chiplets based on die-to-die interfaces like UCIe that you can co-package with your XPU. And that allows you to connect either to another XPU, a network switch, or to a memory appliance. Our technology is also available in IP form, so you can directly integrate it into your ASIC as well. And then we also provide the packaging technology that allows you to package our IP with your ASIC. And together with the chiplet as well as with the IP, you can build what's called scale-up networks as well as scale-in networks. So scale-in networks are typically used for die-to-die communication in multi-die packages, and especially useful as you go from 2 dies per package to 4 and more than 4 over the next 4 years. We also provide an add-in card that we call the PF NIC, or the Photonic Fabric NIC. So this NIC is essentially for server-level connectivity. It's based on PCIe Gen 6, and actually plugs into any server and allows access to our system-level products. Our system-level products are primarily the Photonic Fabric module. This is a module that gives you up to 2 terabytes of DDR5 memory access, along with 72 gigabytes of HBM3E and 8 terabits of electronic switching. And we take that Photonic Fabric module and we build a rack mountable that we call the Photonic Fabric appliance that gives you up to 32 terabytes of in-network memory access. And underlying all of it is our software. Essentially, this software is for link and system management, telemetry, RAS, as well as any predictive insights. So a look at our Photonic Fabric connectivity chiplet. It's based on standard die-to-die interfaces. It could be UCIe A or S, as well as any proprietary interfaces that you may have. We have a protocol adaptive layer, which allows us to support any protocol that the customer may be using, whether it's AXI, UL, CXL, or any protocol that you require. And our Gen 1 chiplet supports 14.4 terabits of bandwidth, which is more than what typically HBM3E requires. So a system level product that we have is called the Photonic Fabric module. This essentially this is the first SoC which has optical I/O in the middle of the silicon. Now, traditionally, all I/O has been located along the edges or the beachfront of the silicon, but with our Photonic Fabric link or PF link, we can have all the I/O right in the middle of the silicon. And what this does is it frees up the beachfront to do other interesting things. What we've done is we've put two HBM controllers, HBM3E. So that allows this SoC to have up to 72 gigabytes of HBM3E capacity, as well as 4 DDR controllers, each with 2 channels. So that allows us to support 8 DDR DIMMs. So this gives the SoC the capacity to address 2 terabytes of DDR with the HBM acting as a cache. So the HBM not only acts as a cache, each HBM has 32 virtual channels, which means you get 64 virtual channels that can be supported by the SoC. And as I said, we have an 8 terabits switch inbuilt into the SoC. So that's 16 ports, each at 448 gigabits per second. What we do is we take 16 of these modules and put them in a rack mountable box. So that essentially means you get 115 terabits of switching capability and up to 32 terabytes of DDR5 capacity and 1 terabyte of HBM. So from a XPU's perspective, as you come into the chiplet, you see the bandwidth of HBM, but you get the capacity of a DDR5. And we have built-in hardware semaphores for synchronization. And this is how all of it integrates. So you can have up to 16 XPUs all talking to this box. You get all-to-all connectivity for efficient collective communications, expert parallelism, etc. Right? And what you get is a unified memory space. So the XPUs see a 32 terabytes of unified memory space at HBM3E bandwidth. So any XPU can read and write to the location. So essentially, things like broadcast and reduce, which today are not possible over collective comms, are then possible through the memory operation. The other connectivity product that we have is what we call the PF NIC. It's an add-in card for server-level connectivity. It plugs into any server that supports CXL 3.0 or CXL 2.0. It's based on PCIe Gen 6. And it offers server-level access to the Photonic Fabric appliance. So you just plug it into any server, and then it can talk to the memory appliance. And essentially through the CPU over CXL, you get about 2 terabits of bandwidth to the appliance. And when you do that, you can have basically 16 servers all talking to this appliance at 2 terabits per second. So traditionally, when you have to go from server to server, right, you go over the front end network, and that's typically of the order of tens of microseconds of latency. But talking to the appliance or talking to the memory, you get memory access at about 300 to 350 nanoseconds, which includes the memory controller or PCIe latency as well. So any server can any CPU in the server or the XPU talking through this to the CPU can basically have full access to 32 terabytes of memory. And what this does is it delivers transformative benefits beyond TCO. So TCO is the bare minimum that you have to do, right? Reduce the cost of operations for any workload. But essentially, it helps reduce sharding because the CPUs or the XPUs can now address the whole 32 terabytes of data at very low latency. And it for very high performance applications, it reduces the tail latency, especially the P99 or P99.9 latency. And as we saw yesterday in one of the presentations, the tail latencies determine your AI application performance. So we believe this will deliver transformative benefit for AI applications and make possible new applications which are not possible today, especially like long context length inferencing, which today are extremely difficult or expensive to deliver. So I was saying the main applications of Photonic Fabric products are, in the scale-up network for XPU to XPU, faster inferencing for reasoning and MOE models, KV cache offload, and delivering vector databases and embedding servings for recommendation models, etc. Lastly, I want to plug our CTO, Phil Winterbottom. He's going to be delivering a more detailed presentation on this next week at Hot Chips. So, please check it out. If you're attending, please, feel free to stop by and say hello. Thank you so much.
Thank you, Ravi.